For years, autonomous software functioned as a committee of distinct, highly specialized robots. Each mechanism focused on a narrow slice of the driving task before attempting to hand control off to the next. The AI model that navigated a tight driveway was an entirely different system than the one steering the car down an open highway. These architectural gaps created real-world friction. If you ever used legacy Smart Summon and stood waiting for the car to move, those long initialization times were the sound of a committee trying to reach a consensus. The limitation wasn't in the car's hardware or cameras. It was a software architecture that relied on disjointed brains trying to hand off control in real time. Version 14.3.2 addresses this by merging actually Smart Summon, standard FSD, and the robotaxi code into one unified neural network. This single-model approach removes the loading delays and handoff friction that used to define the transition from a parking spot to a public road. Now, when you trigger the summon command, the car responds the same second the signal reaches the hardware, navigating toward you without hesitation. Software unification changes the car's personality, moving it from a calculating machine into an instantly responsive entity. You can see the impact of this behavioral shift the moment the car leaves the parking lot and enters a complex residential neighborhood. Because it's running a more decisive model, the car's handling of cross-traffic has changed. It pulls into busy intersections with the confidence of a seasoned driver instead of waiting for a perfectly clear road. Pedestrian interactions have also smoothed out. The jerky, sudden braking of the past has been replaced by predictive, natural deceleration as the car tracks the person's path. Applying a single robotaxi logic to these chaotic streets results in driving behavior that mimics human judgment rather than rigid, programmed calculations. When you scale that logic to a high-speed freeway interchange, the benefits of a single mind become even more apparent. Version 14.3.2 discards pre-programmed lane preferences. Instead, the network reads the natural flow of traffic to decide where it needs to be. This makes for fluid lane changes and a significant drop in the robotic tailgating that used to make FSD highway drives feel so stressful. The ultimate test of this unified system came in the form of a recent coast-to-coast cannonball run using this exact software version. The team drove 2,833 miles from Manhattan to Redondo Beach, California in under 50 hours. The run was completed with zero human interventions, and because of the new software architecture, the car was even able to autonomously park itself at every charging stop. A flawless cross-country trip demonstrates that a unified AI is capable of managing the full spectrum of driving environments without a handoff. However, a unified brain doesn't mean the system is finished. The network is still learning how to handle every scenario at once. Some users report new bugs, like the steering wheel making constant micro-adjustments, or the car aggressively canceling a driver's manual turn signal when they try to override the navigation. And while the system is more decisive in parking lots, it can be confidently wrong, like the recent reports of the software navigating straight into a restricted handicap space. Because everything runs through one neural network, the car's mistakes are now made with a sense of human-like certainty rather than robotic hesitation. The FSD 14.3.2 release marks a departure from the way autonomous systems have been built for a decade. The practice of writing millions of separate rules for specific environments, like parking lots versus highways, is being replaced. This end-to-end unification addresses the segmentation that previously made it difficult for vehicles to transition smoothly between different road types. By giving the vehicle a single mind, Tesla is moving away from machines that follow a checklist.